Morning, Algebra 2. We are going to, we are going to talk about our third method for solving systems of equations, which is elimination. I'll be honest, by far, this is my favorite method, and in my years of teaching, I would say that this is the method that students most typically use, just I think because of ease of process or just the way that it flows. I'm not sure, but it does end up being the one that I usually use and students tend to use. So let's go ahead and fill in the blanks and get you started with how to do this. Number one, you're going to line up the variables. In parentheses behind line up the variables, what I would recommend you do is put your equations in standard form. Ax plus by equals c. You don't have to do standard form. You don't have to do ax plus by equals c, but it is just a way to be consistent. The idea is that your x's need to be lined up, your y's need to be lined up, your equal signs need to be lined up, and your constants need to be lined up. So if you can do that, you'll be ready to go. Step 2, look to see if one variable has opposite coefficients. If it does, go on. If not, you multiply them to make them have opposite coefficients. So opposite coefficients would be like 5 and negative 5, 10 and negative 10, 12 and negative 12. So you need them to be opposites. You have to figure out what to multiply by, and we'll practice that. Number 3, you're going to add the equations together. The reason you're adding should make sense from step 2, right? Sorry about that, my phone just rang. If you are multiplying, if your coefficients are opposites, so if you have a 5 and a negative 5, and you add them together, you will get a 0. It's gone. That's why this is called elimination, because you've gotten rid of the x or the y, whatever it is. Okay, so in step 3, if you get rid of a variable, then in step 4 you only have one variable left, and so you have one variable to solve for. You get that by itself, substitute it in, and then you write your answers in ordered pair or state no solution or infinite solution. So remember, those special cases should still or could still happen. We had some of them in substitution, so x's cancel out, y's cancel out, and you're left with a true statement. So true statement would be infinite solutions. A false statement would be no solution. So those are some of the things you're thinking about. All right, let's go ahead and look at example number 1. So first thing you want to check is, are your variables lined up? X's are lined up, y's are lined up, constants are lined up. So they're all in order. Then you check for opposite coefficients. This has a 2 and a 4. This has a 5 and a 3. They don't have opposite coefficients. At this point, you get to choose. Do you want to work with x's or y's? It doesn't really matter, but there is some ways to make it easier. For example, if I multiply this 2 by negative 2, I'm going to get a negative 4, and this is a 4. Done deal, I only have to multiply the first equation. If you choose to work with y's, you could get them to be 15. That means you have to multiply the first equation by 3, and the second equation by 5. So it's a little bit more work because you'd have to multiply both equations, but it's still very doable, okay? So you can't really go wrong. You can pick x or y to work with. That's completely up to you. So let's go ahead and follow these examples. We chose to multiply by a negative 2 because we want them to be opposites. This one's positive. We want this one to be negative, so that's why it's a negative 2. Biggest mistake I see with students, this negative 2 goes to the x and goes to the y, but it also goes to the 11. So make sure that you're thinking about that when you multiply. So you have a negative 4x minus 10y is equal to negative 22. You just rewrite the second equation underneath that. You don't have to do anything to that. And then remember, our next step was to add. So negative 4 plus 4 is 0, or there's a line through it, so it cancels out. Negative 10 plus 3 is negative 7. Negative 22 plus 1 is negative 21. Divide negative 21 divided by negative 7, positive 3. Take the 3 and plug it in. Does it matter what you plug it into? Absolutely not. You can plug it into the first equation or the second. You can even plug it into the multiplied equation. It doesn't matter. We chose to plug it into the first equation. 2x plus 15 equals 11. Subtract your 15, divide by 2. Answer you've got is negative 2, 3. Okay? Let's go to the next example. Example number 2. Again, check. X's are lined up, Y's are lined up, constants are lined up. So you're good to go with that. Do you have opposites? You have a -2 and 7, you have a 15 and a -5. So no opposites. So you have to do some work. Again, we chose to work with Y's. So we're going to multiply that second equation by 3. So go ahead and multiply by 3. You get 21, -15, and then don't forget about that last one, 51. Again, they're opposites already. One is positive, one's negative. The y's cancel out. -2 plus 21 is 19. -32 plus 51 also gets you a 19. Divide and gets 1. Again, plugging it in, they chose to plug it into the first equation, so -2 times 1 plus 15y equals -32. Add your 2, divide by your 15, you get -2, written as an ordered pair, 1, -2. That's great. Number 3 adds the one twist that we haven't seen yet. Number 3, if you notice, the x's and the y's and the constants are not lined up, which means you have some work to do. So if you see in the first equation, you are going to add 2y to this side, and you're going to add 1 to that side. You're putting it in standard form. So 3x plus 2y equals 1. In this equation, the 3y and the 4x need to switch orders. But notice you're just switching order. You're not crossing over the negatives, or you're not crossing over the equal sign, so you don't need to do like adding or subtracting. You don't need to do opposite operations. So you're literally just switching them. 4x plus 3y, you switch orders, right? It's commutative rule of addition. If you're adding something, you can just switch the order and it doesn't change the value at all. So switch that order around. So again, the first equation, you're adding 2y to the other side, and then you're adding 1 to the other side. In this one, you're just switching the order of x and y. You now have 3x and 4x. You have 2y and 3y. Neither of them are opposites. Again, you can pick what to work with. 3 and 4, you can multiply to make them both 12. You could go bigger than that. You could go 24. You could go, I don't know what else you could do, but you can go higher than just 12, but sometimes it's easiest to do the smallest. If you choose to work with the y's, you've got a 2 and a 3. You can make them both become 6s. You can make them both become 18. You can make them both become whatever you want. That's up to you. If you look ahead, you can tell that we're going to work with the y's and make them both 6s. So this gets multiplied by a 3, and this gets multiplied by a 2. We chose to make the second one negative. That doesn't matter. So the 3 could be negative or the 2 could be negative. That's completely up to you. They chose to make the second one negative. So 9, 6, and 3, because you're distributing, so 9x, 6y, and 3. Underneath there, you have a -8x, a -6y, and then you actually end up with a +4, so be careful with that. A negative times a negative is a positive, so 4. The y's cancel out. 9 plus a -8, or 9 minus 8, is 1. And then 3 plus 4 ends up being 7. You get to be done. X equals 7. You don't have anything more to solve. X equals 7. Take it, plug it in. Again, you can plug it into the first or second of the originals. You can plug it into these equations that are rearranged. You can plug it into those equations that are multiplied. Any of those 6 equations, you can take that 7 and plug it in. We plugged it into the original. So 3 times 7 minus 1 equals -2y. So 21 minus 1, so 20. And then divide by your -2, so -10. So 7 times a -10. And that gets you that solution. All right, go ahead and take out your whiteboards. I'm going to have you practice one on your own. So those are the ones that I want you to try. Yeah, go ahead and try the first one. If you get done with the first one, try the second one. If you could pause the video right now, that would be great. Okay, just checking. I don't know if you guys got your answers to both or not, but I'll tell you them. The first one, the solution should be -6, -5. And the second one, your solution should be 5, -6. So the first one, your solution should be -6, -5. And the second one, your answer should be 5, -6. All right, let's transition back into your notes again. You've got 2 more examples, and you can look ahead already, that's fine. You can tell that these are the special systems. So x's and y's are going to cancel out, and what happens. All right, so let's go ahead and go to the first one. X's are lined up, y's are lined up, constants are lined up. So we know that we can go ahead and do our work. Again, you can work with x's or y's. We're going to choose to work with x's. So we have a 2 and a -4. That means we can make them both a 4 and a -4. So multiply the first one by 2. So you get a 4x, a -10y, and then a -20. Okay, second equation doesn't change, so -4x plus 10y equals 15. Already there, alarm bells should be kind of going off in your head, noticing that coefficients are very similar. So 4x and -4x gone, -10y and positive 10y gone. So you end up with a 0 on that side. That means you have no x's or y's anymore. You know it's going to be a special case. Now it's just a matter on the other side. Is it going to be equal or is it going to be not equal? You have a -20 and a 15. That gets you a -5. Does 0 equal -5? No. So your answer is no solution. Okay? Then you go to your last example. You can predict, obviously, that we're going to give you one that's the opposite, so infinite solutions. So first thing you need to do is make sure everything's lined up. X, Y, constant, you notice it's not. So the second equation, the X and the Y need to be switched in order. You're not using opposite operations because you're not crossing the equal sign. You're just simply rearranging the order they are in. So you have a -3x plus 6y. Okay? Again, your choice. You can work with the x's or y's. We're choosing to work with x's, so we're multiplying by a 3. 3x, 6y, and 30. Second equation stays the same, -3x, 6y, -30. 3 plus -3 is 0. -6 plus 6 is 0. 30 plus -30 is also 0. You end up with a 0 equals 0. 0 equals 0 is a true statement. So you are going to write down the words infinite solutions. Notice these symbols are not enough as answers. You need to write the words no solution or write the words infinite solutions. You cannot leave symbols. That is not okay. So you need to actually be writing those. Okay, go ahead again and grab your whiteboards. And you are going to try these 2 examples on your whiteboards. Go ahead, pause the video, and give the students a chance to work on these examples. Okay, hopefully that was enough time for you guys to be able to get to your answers. The first one you should have ended up with, depending on how you did your work, I ended with a 0 equals 10. Obviously 0 does not equal 10, so that would be a no solution. So the first one should have been no solution. The second one, again, do your work. I ended with 0 equals 0. That's a true statement, and so you would write infinite solutions. So again, the first one was no solution. The second one was infinite solutions. Okay, that's your lesson for the day. So you're going to go ahead and work on your IP for the rest of the class period. If you finish early, take out your technology, go on Haiku, and check your answers. And then when you are finished, you guys can put up your whiteboard stuff and work on homework from another class. But you must finish your Algebra 2 homework before you move on to anything else. Bye, guys. Hope you have a great day.